Bismillahirrahmanirrahim. Assalamu alaikum, dear students. How are you? I hope all of you will be fine and in good health, and also have celebrated the Eid al-Fitr in good way. We have studied a lot of things about the nuclear analytical techniques, and previously in 10 lectures we studied about what is the radioisotopes, what is the stability and non-stability, and how a nucleus gets stability after decaying processes into different isotopes. So all these things, as you know, you have studied about the nucleus of an element, and now we are going to in that part of nuclear analytical technique that is very important. If we see about the analytical processes that we are actually have observed in previous classes, like that atomic absorption spectroscopy, that play very important role in order to measure the elements in different sample materials. So you can say that there is some limitations concerned with these instruments, like that the amount and concentration which is measured by the atomic absorption spectroscopy. So there is a limitation at a low level of concentration. At some time it is not able to determine the quantity and concentration of element in a particular type of sample material. So that is very important thing. So in this regard, there is a need of such type of analytical technique which have ability to measure at any low level concentration of elements or impurities of different elements inside the sample, that is at some level and some time required very important. So in this regard, Neutron activation analysis play a very key role in order to measure such type of materials that is in very low concentration in the sample materials. The second thing that is very important, that is associated with atomic absorption spectroscopy, is the preparation of sample materials. There is a particular type of processes are associated with the preparation of sample materials for atomic absorption spectroscopy analysis, because first of all, there is some liquid processes, some solid processes, and like that. The other important thing is that there is the amount of sample materials. At when we are going to analyze with the help of atomic absorption spectroscopy, some particular type of some particular amount of sample is required, but sometimes the sample material is in such a low quantity that is unable to fulfill the requirement of atomic absorption spectroscopy. So in this regard, we would not be able to analyze the a particular type of element or impurities in particular type of sample materials. So in this regard, activation processes play a very important and key role in order to measure that type of elements which actually bear a very small amount of sample materials as well. So activation analysis, what is meant by activation analysis, and how it is this analysis is achieved. First of all, it should be in our mind, because whenever we are going to analyze with the help of activation process some sort of a particular type of elements or impurities inside the sample materials. So first of all, we have to activate the sample material. So what is meant by activation? You actually going to destabilize the nucleus of an element. So by how we can do this, our concern is not in order to fissile the nucleus. We don't break the nucleus, but we just activate it. We just energize it in order to destabilize. So in this regard, there is some sort of radiations or particle materials bombarded over the target material which do this job, and when it is get activated and have ability to lose this extra energy in order to again get deactivated activation process. So these radiation that actually lost by the target material after activation in order to become deactivated. So these particular type of radiation give a lot of information about different kinds of elements that actually we are going to measure inside the sample materials. So there are two kind of activation analysis. One is the photon activation analysis, and other is the neutron activation analysis. So in case of photon activation analysis, there is gamma radiation that are being used for the bombardment over the target material to get photon activation analysis. So this gamma radiation activate the just have ability to transfer the energy and neither nothing else. So in this regard it is some kind of less important, but if we see about the neutron activation analysis, in this particular type of analysis, one is going to bombard the neutron over the target material. So when a neutron is bombarded over the target material, energy is also transferred to the system, but there is a big destability also occur inside the nucleus, because there is two ways. One is thing is that there is no charge over the neutron and have no any repulsion from the nucleus in order to penetrate in the nucleus of an element. The second thing is that it is massive particle, have a lot of mass. Due to this reason, it have ability to transfer a lot amount of energy into the nucleus. So both things, the penetration of a particle as well as the energy transformation to the system of any atom or elemental nucleus, so both actually highly destabilize the nucleus, and in this regard it have ability to deactivate, destabilize itself. In order to stabilize itself, it emits the radiations, gamma radiation or beta radiation. Both these radiation give a lot of information in order to give you what kind of elements are there and how much quantity of element are there inside the sample materials. So in this regard, neutron activation analysis are much important. So thing is that the basic and main thing that actually associated with neutron activation analysis, in order to determine which type of elements are there, which type of atoms are there in the sample, either the particular type of element which actually we are concerned either present in the sample material or not. So in this regard, it have ability to give you informations. Further, it is very important thing is that it's not a concern, it is unlimitized to a particular type of amount to measure. It have ability to measure a very rare amount of element inside the sample material that is not being evaluated or measured with the help of atomic absorption spectroscopy. So in this, in order to get in initial ages, you can see that how one transfer from usual technique to neutron activation analysis. This is a simple video I have for you. Please see it very carefully.
Let's go back to childhood together, when we used to lap up those cowboy movies. A wealthy lady on a walk down a valley, sunning her alabaster complexion, enraptured by endlessly wonderful natural scenes. But not everything is as idyllic as it seems, and out of nowhere comes a grubby, greasy bandito. Hidden behind the rocks he lurks, waiting for his prey. As soon as he sees his victim, he draws his handguns and leaves his den. He demands all her valuables on pain of death. Well, what is a lady to do? She would rather lose her money than her life. The lady gives up her purse and, sobbing loudly, makes her escape down the picturesque valley. The bandito gets his loot and seems satisfied. But we are out in the Wild West, so how can the bandito be sure it's real gold and not just some worthless substitute? Testing its hardness with his rotten teeth may not be the ideal solution. Dear bandito, give us some of your loot and we will look at it using our reactor. And what has a reactor to do with exploring the properties of materials? The answer is quite simple: neutron activation analysis. This method allows us to examine materials in both qualitative and quantitative terms. And to say it in plain language, we can find out what there is and how much of it there is. Activation analysis has several advantages. The first of these is being able to explore virtually any material we find around us, from asteroid fragments to human brain tissue. Another great feature is that the method is non-destructive. The material being analyzed is left undamaged and can be reused. For the experiment to go well, we do of course need qualified experts and specialized equipment. The cornerstone of the method is irradiating the samples and reference materials in a nuclear reactor, into which the samples are introduced using a custom-made high-tech grip. The irradiated samples are then moved to a special lab. The activated materials emit gamma rays, which we detect in an HPG detector chamber. Each isotope emits a certain set of gamma radiation wavelengths, called a spectrum. By comparing the spectra of the sample with a standard reference piece, we are able to determine the qualitative characteristics of the material. It asks what our sample consists of. To determine the quantitative characteristics, it asks how much there is. We need only compare measured sample values with reference species of known mass, and by means of a simple trinomial and a couple of corrective factors, we can very precisely give the mass of the respective substances. And that is all. The samples, together with the results of the analysis, can be returned to the proud owner with our best wishes for the days ahead.
Yes. So what is the importance of neutron activation analysis you have seen in this video, because there is a simple and classical ways in order to determine the element in the different materials, but neutron activation analysis give you precise and accurate concentration and values of a particular type of element. So in precisely we again repeat what is the neutron activation analysis, and you should know that there is the analytical technique in which radioactive emission are monitored from a sample that has been bounded with neutrons is neutron activation analysis. So in this technique, actually you are going to study the emission of radioactivity that is a particular type for the particular type of element, so which gives you information about a particular type of element. Neutron activation analysis is a sensitive multi-element analytical technique used for both qualitative and quantitative analysis of major, minor, trace and rare elements. One thing should be in your mind, because you have studied about the atomic absorption spectroscopy, and there is a uni-elemental analytical technique. You have ability to determine only one element or one metal at a one time with reference to other particular type of standard element. So in this regard, that is a very cost effective and costly, and as well as a very lengthy process in order to measure each and every element inside the sample material. But if we see about the neutron activation analysis, that is a multi-elemental analysis, so you don't need to measure, and you need to proceed this analysis one by one for each element. Once you actually bombarded the target material, it gives you information about all the element present in the sample material. The further thing is that it have ability to measure major, minor, trace and rare elements. So it have no any difference for either the sample have major element, minor element, trace or rare element. So it is a lot of important in this regard, because it have ability to measure all kind of elements inside the material. The other thing is that neutron activation analysis is a method for qualitative and quantitative determination of element based on the measurement of characteristic radiation from radionuclide formed directly or indirectly by neutron irradiation of the material. The third thing is that is very important and associated with this type of analysis is the qualitative and quantitative analysis. It is not only give you qualitative information about what type of elements are there inside the sample material, but it also have ability to give you information about how much quantity of each element present in the sample materials. The fourth thing is that neutron activation analysis was discovered in 1936 by George Charles de Herse, Hungary, and Hilde Levy, Denmark, and both actually obtained the Nobel Prize due to this work. And so in detail and in some precise way, neutron activation analysis is a ultra sensitive technique. What is meant by ultra sensitive technique? Because it have not only measure the micro and picogram concentration, but it have ability much lower concentration as well, used to determine the trace amount of elements in sample by bombarding them with a high flux of neutrons. So it is very important, and the flux of the neutron should be very high. What is meant by flux of neutron? It is very important. It should be in your mind. Flux mean how much number of neutron going to bombard over the target material in 1 second per centimeter area. So this is called flux of neutron. That should be very high, and measuring the rate of decay of the radioactivity. The second thing is that give you information about the precise element determination. One is the flux of a neutron, other thing is the rate of decay of the radioactive element. The rate of decay of element is specific for each element. This is there is no overlapping between two elements element and between two atoms through decay process and radioactivity processes. So it is important two things. One is the flux and other is decay of the radioactive element. Both give you information about the number of elements as well as the qualitative information of the element. Each radioactive element has a specific and well-known decay rate. There is no any overlapping, there is no any repetition and there is no two element have similar type of decay process as well as the radioactive element spectra. So each element have a particular type of spectra. So each element have ability to determine with the help of this spectra and can be identified. And by measuring the decay rate, the element and its concentration can be accurately found due to this way. The process can be used without destroying the original sample, and indeed has been used on work of art and samples of historical significances. So there is so many things, so many samples which are need to preserve, and no one can afford to waste it. So in this regard, after a lot of number, if you are going to analyze with the help of neutron activation analysis, your sample remain intact. So there is no any harm to the sample material. So it is again remain intact. So you can use it again and again. Okay. So neutron activation analysis, why it is very important in order to meet the demand for the determination of impurities. Because it is the fame of this process is due to because it have ability to determine the impurities, and it should be very accurate determination of impurities inside the sample material give you a high strength materials which actually needed in some kind of missile technology and like that arm technology. So there is a need to determine each and every impurity inside the sample material, because in order to make it a very safe and sound material, so it is very important. So this analysis play very important role and main requirement in order to determine the different kind of element in the sample material as well as the different impurities as well. So it have ability to measure the impurities at ppm and ppb level. So the analytical chemist has turned with the increasing frequency to activation analysis. This technique is based on induced radioactivity. What is meant by induced radioactivity mean? Okay, when you actually going to bombard target material with the help of a neutron, and that target material, that element and that nucleus become activated, become destabilized, and in order to get stability it actually emits the radiation. That radiation have a lot of information about the different kind of elements. So this process actually associated with a number of characteristics. I think in order to go principle of neutron activation analysis, I think I just discuss with you few characteristics of this activation analysis. The first thing is that this analysis is very rapid. It is have no time taking material, because there are so many instruments and so many analysis which actually take a lot of time in order to measure and give you results. Because if you just an example atomic absorption spectroscopy, there is a first process in order to prepare the sample material, that is also time taking, and then the analysis of that sample one by one for each element. So this is a lot of time required in order to measure. But in the case of neutron activation analysis, this is not the case and not associated with this one. You can measure all the element in one way, in one analytical process very rapidly. The second thing is that insensitivity to chemical form of an element. Yes, if we see about the atomic absorption spectroscopy, there is a particular type of form is required in order to get the sample, in order to get the analysis, atomization and then like that. But in this case, in neutron activation analysis, there is no such type of particular type of condition is required in order to analyze the sample material. So there is any kind of chemical form, if an element have ability to measure that one. The third thing is that it is a non-destructive, as I have discussed earlier, that it is a non-destructive technique, and you can use the sample after analytical process and after analysis again and again. The fourth thing is that the high sensitivity if a large particle flux is available. Yes, just I discussed again in previous slide that flux is very important. Neutron flux is very important. So greater the neutron flux, greater would be the sensitivity and accuracy of the material. The fifth thing is that the availability of a signal for automatic recording of results and automatic control of a process. So this is a very important thing. Neutron activation analysis, as well as any other nuclear analytical technique, provided the signal information and on the recording of the result after feeding particular type of values. The sixth thing is that the equipment requirement may be relatively inexpensive. Sometimes some equipment is very relatively inexpensive, but in case of atomic reactor, that is a much expensive one. So these are some kind of the different kind of characteristics that are associated with the neutron activation analysis. Now, what is the neutron activation analysis? How it proceeded? We will discuss in this figure now in detail. So this is a neutron when it is bombarded. This is a neutron actually obtained from different kind of sources. One is atomic reactor source, there is another alpha emitter source, and third one is the gas field detector source. So all these sources have ability to produce the neutron. These neutron and have different sort of characteristic, thermal neutron and fast neutron. So like that, these neutron when bombarded over the target material and it is captured by the target material nucleus. So when it is become a part of this material, the atomic mass of this nucleus is going to increase by 1 unit. So in this regard, because neutron actually increased by 1 unit, due to this reason charge to mass ratio going to destabilize and disturb, and in this regard when it destabilize and so this nucleus act as an activated nucleus. This is called activation process by the bombardment of neutron over the nucleus, and when it is obtained and penetrated inside the nucleus, this nucleus activated, and after activation now it's first of all it want to become deactivation. But when it catch one neutron, exactly after catching one neutron inside it, there is some changes of the nucleons which actually produce gamma radiation after the receiving of this neutron. As this gamma radiation accompanied with the acceptance of the neutron material, a particle inside the nucleus, so these radiations are called prompt gamma radiation. Very quickly, actually, they are liberated after receiving the neutron into the nucleus one. So these gamma radiation play a very important role in order to measure short-lived radionuclides. So after that, when it give prompt gamma radiation, further because there is a mass unit increased by 1 unit, so further it actually neutron because neutron is in excess inside the nucleus, so it will be decayed through beta particle emission. Beta particle emission, how beta particle emission is take place, neutron actually degenerated into one beta particle and proton and antineutrino. So due to this reason, when beta particle is emitted, there is proton found inside the nucleus. So after the formation of proton inside the nucleus, these proton not actually part of the proton shells, but it is present it is formed in the neutron shells. So that proton shifted from neutron environment to the proton environment. Due to this reason, this shifting produces some sort of gamma radiation. So this gamma radiation is called delayed gamma radiation. This process of further rearrangement inside the nucleus by the proton shifting may take place a long time, may take place a short time. So it depends on the arrangement of the nucleus. But it is surely transfer from one side to other side, which actually accompanied with the emission of the gamma radiation. This gamma radiation is called delayed gamma radiation. So by emission of delayed gamma radiation, the nucleus now appear as a stable nucleus, and the charge and the both mass and the atomic number both increased by 1 unit. So it is now stable one. Now there is at 2 points gamma radiation emission take place. One is exactly by receiving of a neutron, by capturing of neutron, and other is by after the beta particle emission, and that may be accompanied with the beta particle emission, or it may be very delayed after a long time, as in case of if you studied, there is a molybdenum and decayed into the technetium, and technetium neutron actually get decayed into degenerated into beta particle, and that proton shift from high energy level to low energy level, and it takes about 6 hours. This is called metastable state. So this is maybe like that process may take place here in order to delay gamma radiations. So these both this is called prompt gamma radiation neutron activation analysis, and this is known as gamma delayed gamma neutron activation analysis. So both activation analysis actually give you information, and this is associated with the short lived, because it is just exactly after the capturing of a neutron take place, and it take place after a long time, maybe 140 days, maybe 10 days, maybe 5 days, but it is a case of in minutes or just like hours. So this is the process in which activation analysis, neutron activation analysis take place. It should be in your mind, the gamma radiation emitted by this nucleus is the only characteristic of this nucleus. The spectra and the pattern and emitted by this nucleus of gamma radiation are here. It is specific for this nucleus. No other nucleus can have ability, can have such type of particular type of spectra which actually formed by this nucleus. So in order to measure how much concentration and what type of element is this in the sample, we can measure by reference sample material, because if you want to just study either it is gold or not gold, you should have to compare the spectra of gamma spectra in delayed gamma radiation pattern or in prompt gamma radiation process with the spectra of the gold element. If it is exactly match with the gold element spectra, so it means it is a gold present in this sample material, and you can easily measure the concentration as well as with the help of emission of gamma radiation, strength of the gamma radiation process. So in this regard, it would be able to get information, a lot of information, qualitative or quantitative way. So dear students, again I would like to repeat the process. Neutron when bombarded over the neutron element target material, the element of the target material get captured and neutron into it, and after capturing the neutron, the nucleus become activated, because there is an excess of neutron inside the nucleus. That neutron, by capturing this neutron, very quickly the radiation is emitted in the form of a gamma, that are known as prompt gamma radiation. Prompt mean very quickly and rapidly emission as a neutron is penetrated into the nucleus one. So these radiation produce a spectra of that is known as prompt gamma spectra, and this have ability about this have a lot of information about the kind of element as well as the concentration of the element. After this, because neutron has increased by 1 unit, and the charge to mass ratio has disturbed, which is related to the stability of the nucleus, this neutron which actually penetrated into the nucleus again degenerated into beta particle plus into proton, and this after the generation, after the emission of the beta particle, the proton get its place to the proton shells, by this shifting from a neutron environment to proton environment, gamma radiation also emitted. These gamma radiations are called delayed gamma radiation emission, because these gamma radiation emitted not by the capturing of a neutron but after the decay process, beta particle decay process. So due to this reason, it is known as delayed gamma radiation. So these delayed gamma radiation, when emitted through the nucleus become stabilized. So these two gamma radiation actually emitted at prompt process, at delayed process, both have a particular type of spectra for a particular type of nucleus. And due to this reason, by comparing it with the standard and reference material spectra, one would be able to get the information, okay, whether the sample is a particular type of element is that one which we are thinking or not, and also the concentration of that element. So dear students, we just complete our lecture at here, and we will tomorrow and in next lecture I will give you a lot of information about the detection process, about the you can say instrumentation process of neutron activation analysis applications, like that. So you should try your best to study all these process in your earlier. So we will see you inshallah tomorrow. Wish you all the best. Allah Hafiz.